Hey guys, hope you've had a good Wednesday. I just wanted to do the second video so we could go over a couple of these problems about work. So today's assignment was practice problems on work, and I know a few of you have messaged me about questions about pretty much all of the questions on this worksheet. So I thought I'd just do a video of going over all of the practice problems so that you can check your work and make sure that you're doing this correctly. I do have a whiteboard here, and I do have some supplies that I went out and bought today. So we're ready to roll. So if you are looking at your worksheet right now, number 1 says, work is required to lift a barbell. How many times more work is required to lift the barbell 3 times as high? And explain. So the way that I was trying to explain it to someone earlier is using the equation. The work equation is force times distance. Force times distance. If we just pick numbers to put in place of work and force and distance, say that the amount of work being done is 6 joules, okay? And then our force is 3 newtons, okay? And the distance, we'll say, is 2 meters, okay? So we have 3 times 2 is 6, okay? So force times distance equals the amount of work being done. All right. This problem wants to know if you triple the distance, okay? So if you triple this number, multiply it by 3, okay? What is it going to do to work? So if we multiply 2 by 3, that's going to give us 6 meters, okay? Force stays the same. Okay, 3 times 6 is going to be 18 joules of work. So what did we just do to our work? We tripled the work being done. So if you triple your distance, it's also going to triple the amount of work being done. Okay, so hopefully that makes a little bit more sense now that I've kind of drawn that out on the board and shown you, because I know some people learn visually. So if that still doesn't make sense to you, I did put attach a video onto the Google Classroom, so you can watch that video and maybe get some clarification on work. Number 2 says, how many joules of work do you do on your physics book when it has a weight of 18 newtons in order to lift it to a height of 0.5 meters? Okay, so that one's real simple. Let me bring up my calculator on Google. So we're going to use the work equation, which is force times distance, and we're going to use our force of 18 newtons. Okay, so work is equal to force times distance. Our force is 18 newtons times 0.5 meters. I know this is a tiny whiteboard, but it's all we've got to work with right now. So 18 times 0.5. Half of 18 is 9. Right? Okay, so 18 times 0.5, 9 joules. Of work being done. Okay. So that is number 2. Number 3, how many joules of work are done on a box when a force of 25 newtons pushes it 3 meters? So we have a force and we have a distance on number 3. So force is 25 newtons times your distance, which is 3. 3 times 25 we know is 75 joules. Okay. Number 4 says 1,500 joules of work are done lifting a 500 Newton weight. How high was the weight raised as a result of this work? Okay, so it wants to know the height or the distance. So in this case, we're going to use a triangle. Right, and triangle for work. Yesterday, I told you guys that work goes on the top of the triangle, force and distance go on the bottom. Okay, so if we're looking for distance, we cover up distance and we're left with work divided by force. Okay, so that's the equation that we're going to use. Work divided by force. Okay, so 1,500 joules of work divided by 500 newtons. Okay, 1,500 divided by 500, that gives us 3 meters is our answer. Okay, 3 meters. Number 5. 70 joules of work are done pushing a cart 3.5 meters across the floor. What average force was applied to the cart while this work was done? Okay, so we're looking for force this time. And we are given distance and we are given work. So force, if we draw out the triangle, the way that we find force is work divided by distance. Okay. Alright, so the amount of work being done is 70 joules divided by our distance, which is 3.5 meters. So we punch that into the calculator. It's 20 newtons. Okay, is our answer for number 5. Number 6 says how many joules of work are done when you lift a 5 kilogram box a vertical distance of 1/2 of a meter. Okay, so this is the problem where I told you about yesterday that you would have to use the acceleration due to gravity, which is that 9.8 meters per second squared. So there's 2 steps to this problem. In order to figure out the amount of work being done, we have to figure out force first. So the way that we figure out force, as we all know, is mass times acceleration, or Newton's second law. Force is equal to mass times acceleration. Okay, so if we do not have this acceleration in the problem, if we're not given acceleration in the problem, we use the acceleration due to gravity, which is 9.8 meters per second squared. Okay, so we'll use the force given to us in the problem on the mass given to us in the problem, which is 5 kilograms, times 9.8 meters per second squared. Okay, and that's going to give us our force. So 5 times 9.8 is 49 newtons. Okay, 49 newtons for force. That is not the answer to the problem. That is only half the answer to the problem. Okay, so now that we have our force, we can determine what the amount of work is going to be done. So 49 newtons of force. Okay, So work is force times distance. We have a force of 49 newtons. And the problem gave us a distance of 1/2 of a meter, or 0.5 meters. Okay. 0.5 meters. I'm sorry that my handwriting kind of sucks. Okay. So, sorry I have to keep switching the camera around, but I have to like move my Chromebook in order to use the calculator. Times 0.5. And that is 24.5. Okay. So 24.5 joules. Okay. Almost done. Number 7 says, calculate the work done when you push with a force of 500 newtons against a wall for 30 seconds. Now, we all know, or we should know from the notes yesterday, that in order for work to be done, you have to apply force and it has to move a distance. Okay, so there's no distance in this problem. Can you move a wall if you push on a wall? If you go ahead and try to push on a wall right now, is it going to move? Probably not, unless it is a really, really unsturdy wall. So, is there work being done? No, there's no work being done because you are applying a force, but there's no movement. There's nothing moving a distance. So this is kind of a trick question. On number 7, 0 work is being done because you are not moving a distance. The wall is not moving, okay? You're applying a force, but there's no distance involved, okay? Number 8, Nellie Newton does work on a box by pushing it with a constant force of 100 newtons over a distance of 4 meters. A, if Nellie pushes the object with twice the force over the same distance, how much work does she do? Okay, so let me read that one more time. Nellie Newton does work on a box by pushing it with a constant force of 100 newtons over a distance of 4 meters. So she's moving with twice the force over the same distance. So it's going to be 200 newtons. Okay, twice the force would be 200 newtons over 4 meters. So how much work is she going to do if she is going pushing with twice the force? So 200 newtons times 4 meters. Okay, so 2 times 4 is 8, so that's 800 joules of work being done. Okay, so all we did here was double the amount of force. Okay, that's on A. On B, it says if she pushes with the original force, 100 newtons, over 8 meters, how much work does she do? Okay, so let's see what that comes out to be. Original force is 100 newtons. Okay, over 8 meters. So 1 times 8 is 8, so that's also going to be 800 joules. Okay, so A and B come out to be the same answer. Alright, so number 9 says a 50 kilogram physics 1 student, trudges from the first floor to the 3rd floor, going up a total height of 13 meters. Calculate the work done by the student. Okay. So, there is another equation that I'm going to go ahead and introduce you to. Okay? Let's see. Well, mass times distance. Nope, never mind. We'll do this one the same way that we did the other one, which was number 6. Okay, so forget I said that. Sorry. So we're going to figure this one out as a 2-step problem, okay, instead of using the other equation that I will not mention. So we will have to figure out force first. And like I said before, since there is no acceleration in the problem, we will use the acceleration due to gravity, which is 9.8 meters per second squared. So again, Newton's second law. In order to figure out force, force is mass times acceleration. Okay, so our mass is 50 kilograms. Our acceleration is 9.8 meters per second squared. That's the acceleration due to gravity. And since we're talking about something that is vertical up and down, talking about something going against gravity, that's the reason we use the acceleration due to gravity. Okay, so and then when we multiply those two numbers together, we're gonna get 50 times 0.8, 490 newtons. Okay, 490 newtons is our force. Alright, so the next step in this problem, final step in this problem, is to figure out the amount of work being done. Okay, so 490 newtons is our force. So we got 490 times 13 meters. Okay. So 490 times 13. 6,370 joules. Okay. Alright, so that wraps up all of the practice problems that you guys were supposed to have done today as NTI assignment. Hopefully that cleared some things up for you guys. If not, message me. Let me know what you're confused about. I will try to clarify as best as I can. I'll try to find more resources for you to look at online if you still don't understand it, okay? Let's see. Tomorrow, what do I have for tomorrow? Classwork. Okay, tomorrow is an introduction to power. I will post a separate video on power, okay, because I don't want to overload you today, okay? So tomorrow I will go ahead and do it now, but I will post the video tomorrow so you're not totally overwhelmed. And then on Friday, let's see. Okay, there is a Nearpod. Had we been in class, I would have done the Nearpod with you over power to introduce power. And there is a note sheet on power that you're going to have to look at. So if you'll skip straight to slide 7 on the Nearpod, because there is a quiz on there about work. You're not going to take that, okay? I will set up a different quiz for work. I mean, you can look at the questions, and if you want to practice those, that's fine. But it's not going to be graded, okay? It's not an interactive Nearpod that I can see what your answers are. So if you want to do the practice at the beginning, that's fine. You don't have to, but to get to the notes for power, you're going to have to skip to slide 7 on the Nearpod, and that's where you'll start your notes from. As far as the test that you guys took on Monday, everyone should have transferred their answers over to the electronic version. If you haven't done that already, you need to do so as soon as possible. Do it by Friday. Have that done by Friday so that I can put your grade into Infinite Campus on Friday, okay? So it will give you your grade, okay, as soon as you submit those answers. Make sure you're matching them up the way that you have them on your actual paper physical copy, okay? If you have any questions about that, please let me know, okay? That is a summative grade, all right? Trying to think if there's anything else I need to talk about before I let y'all go. I think that was it. But if y'all have any questions, just let me know, okay? I'm usually available all day, and I will be available tomorrow, okay? And I will also make that video in just a minute, okay? So, I'll talk to you guys later. Have a good day.